All right, now we're doing 7Q speed control. This is by G964, and 85% of the people like it. In John's car, the GPS records every S seconds the distance traveled from an origin. The distances are measured in an arbitrary but consistent unit. For example, below is part of a record with S equals 15. All right, so it travels this much in 15 seconds, this much in 15 seconds, blah, 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 blah. All right, and that's what we just said right there. And we can calculate John's average hourly speed on every section we get. And we get these, all right? So given S and X, the task is to return an integer the floor of the maximum average speed per hour obtained on the sections of X. If X length is less than or equal to 1, return 0 since the car didn't move, all right? And then with floats, it can happen that results depend on the operation's order. To calculate our hourly speed, we can use 3600 times delta distance divided by S. All right. So, with all that said, what we're going to do to start with is declare a variable. We're just going to say let result equals 0. And then for this, we're also going to take care of this edge case, where it said something about, if x is less than or equal to 1, we're going to return 0. So if x is less than or equal to 1, we're going to return 0. All right? Now that we've got the easy stuff out of the way, let's try to figure out what we're going to do here. So we're going to have to iterate through this thing. That's a given. All right? And then on the iterations, we're going to have to subtract this from this on each one. So we're probably going to have to start at, at like x equals, like index equals 1 or something, or maybe something like that. And then we're going to have to just subtract somehow. I guess we'll just start at the index, and then we'll subtract this from index plus 1, and that might as well do it. All right, so let's knock that out. Let's say down here we're going to start a for loop. We're going to say, that's not where any of this goes. All right, give me a second. All right, give me just a second. All right, so now we're going to say for let index equal 0. We're going to say when index is less than, what is it we're doing? We're going to do, x dot length minus 1, since we're not going to do this like an x plus 1 minus this one, all right? So we're going to say, and then we're going to say index plus plus to iterate through. All right, so now we're going to say, that let speed equal, and then we're going to first get this delta x. Actually, let's just do 3600 times, and then the delta x is going to be, delta distance is going to be, what is it going to be? It's going to be x at index plus 1. So x at index plus 1 minus x at the current index. And what did they say? Divided by s. And then divide that by s, right? And that's what the speed is going to be. And then to find the max of it, we're going to go in here, still in the for loop, we're going to say if speed is greater than result equals speed. And then we're going to return result. All right, let's see if this works. Test it out. All right, good. Attempt it. Awesome. and it's 63 milliseconds. That looks like something we can beat. Let's give it a shot, because this is definitely an awful lot of typing. Let's say const here, GPS equals this, and then turn all this into an arrow. All right. Pardon me. So on this, we're going to be doing a Math.max, because that's the first thing we're going to have to worry about is getting the maximum. Excuse me, the last thing we're going to, no matter what, we're going to get the maximum of whatever we're doing. So the Math.max function returns the largest of the 0 or more numbers given as input parameters. So we're going to say Math.max, okay. And in here, we're going to do x, but we're going to do x.slice. But we can't do that inside of a function without using the spread syntax. And the spread syntax allows an iterable such as an array expression or string to be expanded in places where 0 or more arguments or elements are expected, all right? So because right now x is inside these brackets, and Math.max doesn't accept brackets, it accepts, what does it accept? It only accepts things separated by commas. So that's what the dot's for. So x dot slice, all right? And the slice basically just slices off wherever we're going to hit it at. So right here it says slice at index 2, so 0, 1, 2, camel all the way out. So with here we're going to slice after this 0, because we don't need the 0 when we're doing concise syntax. So we're going to slice it at 1, all right? And then we're going to do a map, a map method. And the map method basically creates a new object, a new array populated with the results of calling a provided function on every element in the calling array, okay? So like 1 times 2 is going to be 2, and then the next element is going to be 4 times 2, 8, and then blah, blah, blah. But on this one, when we do map, we're going to not only have the element, but we're also going to have the index as well, because we're going to be subtracting this one from this one, this one from this one, and whatnot, right? So we're going to do map, and then we're going to say element index, right? Because those are the 2 arguments we're going to be using. And then we're going to do, like we said before, the 3600 times the delta x, which in this case, it's going to be element minus x at the current index. And this isn't this x that's been sliced. This is the regular x. So it's going to be like this at element in this one at 0 is going to be 0.23, but at 0 over here it's going to be 0. So that's how we're doing that little trick. And then right here we're going to say divided by s. All right. Now, like it says over here, we need to find the floor of this. And usually I would like to do like a math.floor, but since we've already got a math.max going over here, math.floor doesn't working as well as we'd like it to. So, but there's always another way to do to round down. And that way we're going to use this bitwise OR operator, which returns a 1 in each bit position for which the corresponding bits of either or both operands are 1s. Now, what does that mean to us? It means that if there's a 0 here, check this out, and this has anything after the decimal place, and you do an OR, you do the bitwise OR right here, it'll do 5, just like that. And there's also the XOR, which is basically a caret like this, and it does the same thing. So if you ever need to use math.floor and you can't use it because of something like this, because of an extra case, you just do, there we go, that'll give it to us. let me show you, test it out. Look, it worked. All right, and let's attempt it, and let's see how fast we went on this one. Well, it doesn't matter, because that's like almost, that's 39 more than milliseconds than the other one. So this one definitely is the big loser today. Let's just go right back here and say test, attempt, and submit. All right, very much like this one. Let's go to my solution. Just me on this. Best practice in my opinion, and we'll see you next time.